Hi everybody, Mr. Wyatt here, and today we're looking at topic 7, section 6. We're talking about surface area of prisms today and how to find the surface area. When we're talking about surface area, we're talking about the entire outside coating of the figure. If you look at this example here, we have a box, a cardboard box. It says fragile, so we're going to want to handle this one with care. Um, but when you look at this box, it does have 6 separate faces. We have a top, below that is the bottom. We have a right here and a left here, and then here's the front, and here is the back. If you were to cut down the seams on this and open it up and lay it out flat, it might look kind of like this here. You have 1, 2, 3, 4, 5, 6 faces, all showing there laid flat when you cut the box open and lay it down. This right here is called the net of this figure, okay? A net is when you take a three-dimensional figure and you lay it out in 2 dimensions. Okay, so if you create a net for these, it can make it a little bit easier to find the total area of the entire surface of the figure. Now this box happens to have dimensions that are all the same. Every one of them is 9 inches. It has a length of 9 inches, a height of 9 inches, and the width over here as well is 9 inches. Okay, so if I want to find the total surface area of this figure, I could find the area of just one of the 6 faces. They're all identical. And see, this here is 9 inches, and then this dimension here is 9 inches, the same as this here. And if I multiply 9 by 9, I get an area of 81 square inches here. That means all of these, since the dimensions are all the same, every one of these has an area of 81 square inches. So what I could do is take 81 times 6, since I have 6 faces here, and that'll give me the total surface area for this box. All right, so we get 486, and its area, so it's square units. We have square inches. Okay? So when you see cubes and you see cubes on your assignment today, you should smile really big because those are the easy ones. You just find the area of one of the faces, and since all 6 faces are identical in size, you multiply by 6 to get the total surface area. All right, let's look at another example, but this time it isn't a cube, it's a rectangular prism. And so it won't be quite as nice, but it won't be bad. Kelly wants to cover a shoebox with decorative paper without overlapping the paper. How much paper will she need to cover the box? And I have all of these 6 faces that are going to be covered with this gift wrap here. Now, normally when we're wrapping a box, we would overlap things a little bit, but she's going to do this so none of the paper overlaps. So it becomes a surface area question. So what you could do is draw yourself a net. And so we have 6 faces again. 4 of them are larger. You have these 2 end caps that are a little bit smaller. Okay, so if you look at this, you can see the top here. I'll go ahead and trace the top here so you can see it a little bit more clearly here. The top is 10 inches by 8 inches. I'll shade this in here. All right, and when you look down at the net, we have a 10 by 8 inch measurement right here. Now, if the top is 10 by 8 inches, guess what? The bottom is also 10 by 8 inches, and you can't see the bottom since it isn't a see-through box, but it would be down below there. It's also 10 by 8 inches, and that's what you see in your net right here, 10 by 8 inches. Now, the right-hand side over here, and I can switch my color here to trace this. Here's my right-hand side. What are its dimensions? Well, it's 10 inches, but this time it's by 6 inches. And so if I were finding the area of this face here, I can show it right here. Here's 10 by 6. And there's another 10 by 6 across from it right here. And that other 10 by 6 would be on the left-hand side, kind of hidden back here on the other side of this box. Okay, that's 10 by 6 also. And then we have the front and we have the back. Like here's the front right here. I'll just shade it in here. Maybe I'll go like this so it really shows up well. And its dimensions are 8 inches by 6 inches. And the back side is also 8 inches by 6 inches. And that's what you see here and here. Those are the two sides that are 8 by 6 inches. So if you find the area of each of these individual rectangles, and then add all of those areas together, it'll give you the total surface area of this box. And then if you're covering it with that decorative paper, that gift wrap, that's how much gift wrap you would need to cover that box. Okay, so you can see here all of these dimensions, 8 by 6, we multiply that 8 times 6, we get 48. Same thing here, 8 times 6 is 48. 10 times 6 was 60, that's the same thing here. 10 times 8 is 80, same thing here. So if you add all these numbers together, and yes, you should use a calculator. If you add all these together, you get 280 plus 96, that'd be 376 square inches for the total surface area of this prism. Okay, some people will organize it a different way instead of using a net, but I think nets are very nice. If you want to do it without using a net, what you can do is kind of separate this rectangular prism into its 6 faces. But some of the faces are the same. The top and the bottom are the same. The top is 10 by 8, so is the bottom. So if you take 10 inches times 8, that's 80. That's the area of the top. If you then double that by multiplying by 2, you get 160. That's the top and the bottom together. Okay, so I'm organizing this by putting the top and the bottom. I'll just abbreviate T and B there. Now you can also combine the left and the right sides. I'll call it L and R. So looking at the right side here, that's 10 by 6. The left side is also 10 by 6. So I could take 10 by 6. 10 times 6 is 60. But since the left and right are the same, I can double that and get 120. And I'm going to get myself in my own way here. So I'm going to move my picture up here so you can see this. All right, and then finally we have the top and bottom, left and right. We also have the front and the back. So I'm just organizing all the different sides, the faces. And the front here is 6 by 8. The back is also 6 by 8. So if you take 6 times 8, you'll get 48 for your area. Now we can double that because both the front and the back are the same. 48 times 2 is 96. If I add all of these together, it should equal 376 square inches, the same as what we get when we use a net. And let's see what we get here. We have 6, 8 plus 9 is 17, carry the 1, 1, 2, 3. So yes, I do get 376 square inches. It's just another way that you can handle rectangular prisms. And you might have seen this before. I don't know if you did this last year, maybe in 5th grade or not, but just separating top and bottom, left and right, front and back, organizing it that way, since the opposite faces happen to have the same values for their areas. They have the same length and width. All right, let's look at another example here. Sam built a storage cube, a cube out of plywood. How many square meters of plywood did Sam use for this cube? Okay, and so it's a 1/2 meter by a 1/2 meter by a 1/2 meter. It's a cube. You can lay it out like a net like this. And this is like our first example. This is kind of a nice one because all 6 faces in a cube are identical. So what I could do here is just find the area of one of these 6 faces, and that would be 0.5 times 0.5. You can use a calculator for this, but 5 times 5 is 25. And then you just move the decimal point in 2 spaces. So we get 25 hundredths for the area of one face. Now remember, in a cube, all 6 faces are identical. So now if you multiply this by 6, it'll give you the entire surface area of this plywood cube that Sam built. Okay, so 0.25 times 6, let me show my work here. You can use a calculator, but 25 times 6 is 150, and then you move your decimal point in 2 spaces. You get 1.50. Now I don't have to show the 0 at the end, so I'm just going to write 1.5 square meters. That's the total surface area of that cube. Oh, cubes. If only every question was a cube. Wouldn't that be nice? All right. Now, what if we have a triangular prism? Let's find the surface area of this triangular prism. So we have a triangle here, a right triangle. It's 9 by 12. The other face opposite that is also a right triangle with a height of 9 and a length of, or a base of 12. But then the other 3 faces are all rectangles. We have one right here that's 18 by 15. We have one on the bottom that's 18 by 12. And we have one on the back that's 18 by 9. It's easier to see if you lay it out as a net. Okay, so here's your 18 by 9, here's your 18 by 12, here's your 18 by 15 rectangles. And then we have these 2 triangles. So what we have to do is start by finding the area of these rectangles. This is easy. This is 18 times 15. And you can use a calculator to find that. This one here is 18 by 12. So you take 18 times 12. And this one here is 18 by 9. So we take 18 times 9. Should we just do those quickly? Let's go ahead and do that. So this would be 162, and yes, you can use a calculator. This one here would be 216, I believe. 180 plus 36 is 216. And then 18 times 15, that'd be 270. Did I get that right? 180 plus 90 would be 270. Again, use a calculator when you're doing that, and you'll be fine. Now, how do you find the area of a triangle? Well, to find the area of a triangle, we have to use this formula, 1/2 times the base times the height. Well, in these triangles, the base is 12 and the height is 9. In right triangles, the base and the height are your legs, the sides that form the right angle. So we have 1/2 times 12 times 9. Okay, well, half of 12 is 6, and 6 times 9 is 54. Okay, so that means this triangle has an area of 54. This triangle has an area of 54. So to find the total surface area of this figure, I can just add all of these numbers together. And so I have 270. I have 216. I have 162, 54, and 54. Notice in a triangular prism, there are only 5 faces. Okay, so when we add these all together, let's see, we have 6, 8, 12, 16. Carry the 1. 8, 9, 15, 20, 25. Put the 5 there, carry the 2 here. 4, 6, 7. It looks like it's 756. Now a label, we're dealing with centimeters here. Area is square units, so we have 756 square centimeters for our surface area for this figure. All right, I have some triad examples here, but honestly, we don't have a lot of time left. We've worked on the cube, so let's just skip that one. And I might just have time to help you organize this one here. Again, what we have here is a triangular prism. Anytime you have a three-dimensional figure that has rectangles, kind of like this rectangle here, it's a prism. But what makes this unique is it has end caps that are in the shape of a triangle. So it's a triangular prism. You can find the area of all the rectangles. We have this one here, which is 7 by 5. We have the one on the bottom, which is 7 by 6. And we have the one over here. What are its dimensions? Is it 7 by 5 also? So we have to find the area of all of those rectangles. But then we have the triangles, which have a base of 6 and a height of 4. So there you'd have 1/2 times 6 times 4. But then you have 2 of those, so you're going to have to do that again. Okay. I'm about to run out of time, so maybe your teacher could run through that with you, and I'll see you tomorrow.